This report shows the status of Aris 1 and 2, the Generals Taylor and Callan, as they appeared during the last week of November 1962. Previous reports showed a history of the program from the beginning. You saw the instrumentation hardware in the manufacturing stage and the start of the all-important installation, checkout, and integration phase, which is now in full swing. Here at Bethlehem Steel Shipyards in Brooklyn, work on the two ships proceeds simultaneously. The Taylor, which you see here, follows the Callan by about 3 months. On 24 November, in a now familiar scene, the Taylor received its first antenna mount for the C-band radar. All of the long-run cables had been pulled and wiring to mock-ups was just about complete. Computer equipment had been wired and was being installed. Over here at the Callan, the two radar antennas are in place, and telemetry antenna number 2 at the left, bearing a dummy load, permits servo checkout to proceed until the calibrated antenna number 1 is ready to be installed. This expedient is saving valuable time. At Callan's stern, the weather balloon hangar and launching deck are taking shape. On the superstructure deck, the Arcus rocket launcher base is in place. Above, on the highest deck, astern, the weather balloon tracker shelter stands ready for its GMD-2 radar. This shelter is made of bolted-together translucent fiberglass segments. It sits directly above the weather offices, and sheltered access from them is through a hatch inside the dome. On the same deck, outside the shelter, bases for 2 of the communications whip antennas were in place. By the end of November, the aft whip antennas were in place. Callan's boilers have been supplying steam to ship's machinery since light-off in September. We'll see the machinery room later. The 2 vertical tubular objects near Callan's bow are helical antennas, also part of the versatile communications equipment. The cages behind the sign on Callan's superstructure deck shield 6 large transformers. They supplied temporary power to the instrumentation system while the turbo generators were being checked out. This was one of a number of steps inaugurated by management to maintain the ICI schedule. This barge moored beside the Callan mounts heavy electrical resistors that are used to load the 3 turbo generators during tests. The massive cables connecting the barge and the generators run through a temporary hole cut into Callan's hull at the 3rd deck level, amidship at the L-band transmitter. From the temporary porthole, the cables snake across the deck to a trunk leading to the turbo generator room, 1 deck below on the 1st platform. Here the cables run overhead to the power control panel, which also distributes temporary power to the ship's instrumentation. This rotating armature belongs to one of the 3 2,000 kilowatt turbo generators. Steam from the ship's own boilers powers the turbines. These generators supply basic 60-cycle power. Power for normal ship services is supplied by generators located in the engine room. During initial runs, generator number 1 vibrated excessively because of misalignment of the rotor. It was removed, reworked, and balanced, and reinstalled. The engineer with the strobe light is making dynamic balancing tests. Here is the control panel and one of 2 motor generator sets that convert some of the 60-cycle power to 400 cycle. Here in the machinery room, steam warms one of the propulsion turbines. All such turbines require an 8 to 10-hour warm-up period before they can be turned over. Likewise, they require a similar cool-down period. When properly heated, they will be operated at slow speeds while the ship remains tied to her moorings. Duty engineers keep a sharp watch on the boiler performance every minute of the day. This indicator panel shows the status of boilers, feed water, steam pressure, and condition of lubricating oil second by second. An inspection window shows the condition of the oil burners. Before the turbine turns under steam, an electric motor drives the propeller shaft at a very slow rate, 1 revolution in 5 minutes. Later, the ship still moored, the turbines revolve it at no more than 5 revolutions per minute. At this lighted inspection window, duty engineers run a visual check on the machinery loop. Up forward on the Callan, a technician checks out the Sperry gyro pilot in the wheelhouse. Basic cable runs are complete here. Only the finishing work is needed. Much of the original equipment will remain in service. In the ship's hotel spaces, neat but not gaudy is the word. In the officers' and technicians' lounge, workmen are finishing the walls and ceilings of the 20 by 60-foot room. The galley is being outfitted with new stainless steel electric ranges and ovens. Refrigeration equipment has been tested and put into operating condition. In the hospital area, lights for the operating room are in place. Other medical facilities will include a dentist's office, consulting rooms, hospital beds, and X-ray equipment. Here is a typical two-man cabin for members of ship's instrumentation crew. In size, arrangement, and furnishings, the rooms are the same as the passenger staterooms aboard the Callan when it was in the Army's transport service. New floors have been laid and they are protected by heavy paper coverings while the furniture is being repainted. Hardware, lighting, and plumbing have been repaired or replaced, and air conditioning has been installed. Returning to some of the mechanical features of the ship, we see the liquid nitrogen generator. This compact unit will supply cooling for the parametric amplifiers in the C-band and X-band radars. Chilled water for the air conditioning units located throughout the ship flows from two 300-ton capacity primary units. Each could adequately cool a 15-story office building. Looking at the top of the hatch well rising from the L-band transmitter room, you can see the hoists and guides that are used to transfer the SAL 153 klystrons to and from storage. As we descend from the superstructure deck to the third deck level, you can see the top of one of the two 8-foot high klystrons. There are two klystrons because each radar is polarized both horizontally and vertically, so that each C-band, X-band, and this L-band is really two radars, a total of 6 on the ship. Against the opposite wall of the hatch well is the other klystron. The 44 major units of the L-band transmitter are now installed and checkout is underway. The high and low power drivers are ranged along the port bulkhead in the distance, and two single sideband modulators stand in the foreground. In this, the larger of two rooms housing the X-band transmitter, the 24 major electronics units are in place. Behind the video load assembly, engineers prepare to install one of the two klystrons. They remove it from the padded shipping case and bolt it to the built-in lifting device. Then it is raised and swung over and lowered into its pulse tank. The third of the 3 radar transmitters, the C-band, is also the farthest advanced. On 29 November, the complete C-band portion of the IIR, or Integrated Instrumentation Radar, underwent an operational performance check, utilizing transmitters, receivers, rangers, microwave plumbing, and servos. The New York skyline was painted in an A-scope presentation. Through the open hatch above the IIR room, the C-band tracker antenna appears against the evening sky. Critical work in this room is proceeding on 3 shifts. Normally, 40 or more engineers and technicians are at work on checkout or integration tests in this area. To avoid interfering with their work, these scenes were made just before the second shift arrived. Certain types of work, such as rework of electronics and architectural finishing, are deferred to the second and third shifts, so that critical integration tests can proceed unimpeded during the day. The 37 major units in the IIR room consist principally of servo controls, rangers, receivers, and control consoles for all 6 of the instrumentation radars aboard. The radars, of course, are the real reason for sending the ships to sea. The master console controls all of the radars, and the operator can assign secondary targets to each of the other 2 consoles. In the new navigation control center above the wheelhouse, all equipment except the star tracker was in place. By the last week in November, the SINS checkout was complete, and acceptance testing was well along on the other equipment. The lighted panel is on the navigation console. Looking in the opposite direction through one of the passages beside the locked SINS compartment on the right, you can see recording, intercom, and LORAC equipment. The ladder leads to the Star Tracker dome above SINS. This is timing and telemetry room number 1. The near cabinets house telemetry antenna control stations, and wooden slats protect equipment in this narrow room while mechanical work continues. At the far end of the room is the complete high-precision timing equipment. The left-hand racks hold the basic timing units, a pair of redundant, highly stable 100 kc oscillators. A radio receiver on the right picks up precise Bureau of Standards timing signals from any of 5 stations. Next door, in telemetry room number 2, technicians were completing installation of pre-detection equipment, pen recorders, and retransmission equipment. Checkout began shortly after these scenes were made. A short month and a half before these scenes were made, decks, bulkheads, and overheads were festooned with miles of cables that now are largely hidden. Inside the weather offices at the Callan's stern, architectural and mechanical details are nearly complete. Air conditioning and lighting have been installed, and desks and cabinets are in place. Controls and recorders for meteorological equipment stand behind protective coverings. The Arcus rocket control station is at the far end of the room. In the computer room, all equipment is in place. SATS tests are complete and integration tests are in progress. The guard writing at the table logs visitors into and out of the room, now standard procedure in the principal instrumentation areas. At the opposite end of the computer room, which runs completely athwart the ship on the 3rd deck level, are desk space and record and tape storage cabinets. Desks are bolted to the deck and lamps are fixed to the desks. Ceilings and exterior bulkheads are insulated. The box-like structure against the far bulkhead conceals motor generator sets for the computer. A local air conditioning unit occupies one corner of the room. Next door to the computer room, the calibration laboratory is under construction. Secondary instrument standards directly traceable to the Bureau of Standards will be on hand to calibrate the ship's test instruments. Here is the Operations Control Center, where integration tests are in progress. The center houses the master control console, the target trajectory plotter, and the smaller designate control console. The target trajectory plotter on command from the computer plots cross range and trajectory of the target. If you look closely, you can see the pen tracing lines as the engineer checks alignment of the moving arms. The television display on the master console will be connected to a bore sight camera on one of the radar antennas. This completes our views of the Callan's interior spaces as they looked during the last week in November. Earlier, we said that the C-band transmitter had been given an operational check. Whenever a radar is transmitting, deck spaces are roped off and cleared of personnel. Then an engineer and the project safety officer take radiation measurements with a portable antenna and meter. At this stage of the work, whenever the nature of the work permits the mounts to be cleared of personnel, the antennas are exercised to check the servo systems. This is the C-band antenna. At the beginning of December, all major electronics equipment except the Star Tracker and telemetry mount number 1 had been installed on the Callan. By using various schedule recovery measures, such as temporarily substituting telemetry antenna number 2 for number 1, checkouts or integration tests were underway on most subsystems. The coming weeks will see an intensive effort to complete the installation, checkout and integration phase in preparation for dockside and sea trials.